Today, we're going to dive deep into the world of manufacturing. We're talking about an invisible but incredibly powerful force that pretty much shapes everything around us, from the phone in your hand to the engine in a jet.
So let me ask you a question. Think about your phone, your car, maybe even a life-saving medical implant. What's the one thing that decides how good they are, how much they cost, and how long they last? It all comes down to controlling one single critical variable, and the answer is something called cutting force.
Okay, so what is cutting force? Well, in simple terms, it's just the resistance a material puts up when you're trying to cut it or shape it. But, it's so much more than that. I love this analogy. It's the vital sign for the whole manufacturing process. If you get it right, you get perfection. But if you get it wrong, well, that's when things get really complicated and really expensive really fast.
So let's explore that ripple effect. How on earth can this one single metric, this one force, change absolutely everything about making something?
And believe me, the difference is like night and day. On one side, with high cutting forces, your tools are going to wear out super fast, the surfaces you create are rough, and the whole process is just unstable. But when you manage that force correctly, your tools last longer, the quality is way higher, and the whole operation becomes way more efficient and predictable. Let's break that down a bit. So, high forces, they directly cause tools to wear out and give you a poor surface finish. That's a given. They're also a direct measure of energy use. More force means you're burning more power. And for some of these really advanced materials like carbon fiber composites, too much force can cause something called delamination. That means the internal layers of the material can actually pull apart, creating invisible damage that can seriously compromise the strength of the final part. Not good.
Of course, this isn't some one-size-fits-all problem. The material itself is a huge part of the puzzle. Every single material brings its own unique challenge to the table.
And you can really see the range of challenges here. You take a common steel, and it might generate forces that are high, but at least they're stable. A composite, though, it creates these fluctuating forces that can literally pull its own layers apart. And then you get to the really tough stuff. Super alloys like Inconel and titanium, the kind of things we use in jet engines and spacecraft. These materials generate such extreme forces and heat that they push our manufacturing capabilities right to the absolute limit.
And here's the great paradox, right? The very reasons we want to use these materials are the exact same reasons they're so difficult to machine. Their incredible strength, their amazing resistance to heat, that's exactly what creates such massive resistance, such incredibly high cutting forces.
So, if the problem is basically built into the material, how do you solve it? Well, this is where innovation comes in. Let's look at some of the absolutely brilliant strategies engineers have come up with to tame this force.
Engineers have cooked up some incredible techniques. They can use these advanced nanolubricants that act like microscopic ball bearings to slash friction. Or they can preheat the metal with a laser, just milliseconds before it gets cut, which makes it temporarily softer and easier to work with. And then there's ultrasonic vibrations, where they make the tool oscillate thousands of times a second to get a much cleaner cut. It's amazing stuff. And the results from these techniques, we're not talking about small, minor improvements. In some cases, the change is absolutely dramatic. For one notoriously difficult material, one of these strategies was able to reduce the cutting force by more than this.
That's right. By preheating a super tough titanium alloy, researchers got a more than 60% reduction in cutting force. That's not just an improvement, that is a total game changer. It turns a process that was incredibly challenging into something much more manageable and much more economical.
But managing the force isn't just about these clever physical tricks. The real future is about making the entire process intelligent. It's about sensing, predicting, and adapting all in real time.
This is creating a whole new generation of smart tools. We now have tool holders with sensors built right into them, feeling the force every single second. AI can then analyze those signals, combine them with data from machine vision, and use neural networks to predict what's about to happen. It can then adjust the process on the fly to prevent an error before it even starts.
And that right there is the key. As all the recent research points out, being able to analyze these force signals lets us spot problems before they happen. It's like hearing a tiny tremor just before an earthquake. It gives the whole system enough time to react and prevent a total failure.
So what this all means is that we're seeing a fundamental shift in how we think about manufacturing. We're moving away from a world where we find a flawed part after it's already made to a world where the machine can actually predict and avoid the flaw completely. We are literally shifting from just reacting to problems to actively predicting perfection.
Which leaves us with a pretty fascinating thought to end on. If we can perfectly sense, predict, and control this unseen force for any material out there, what does that unlock?
Are we about to enter a new era where materials and designs that we once thought were impossible finally become a reality? It's a really exciting future to think about. Thanks for exploring it with us.